Okay, so this is LeetCode problem 450. Delete node in a BST. Given a root node reference of a BST and a key, delete the node with the given key in the BST. Return the node root node reference, possibly updated, of the BST. Basically, the deletion can be divided into two stages. Search for a node to remove. If the node is found, delete the node. So this is going to be pretty difficult. I mean, deleting, if we delete a node, what happens to the children? That's the first question that I get. I'm not too familiar with that. So if it doesn't have any children, that's, I mean, pretty easy. So this one, they delete the 3, and then the 4 just comes where the 3 is. Given the key to delete is 3, so we find a node of 3 value and delete it. One valid shown. Oh. Okay, so we delete the 0, nothing happens. So 5, 2, 5, 2, 6, and then no. Okay, so when we deleted okay, so if we delete it and it has 2 children, one of the children go and then the other one stays. Okay, that's cool. So I'm guessing if it only has 1 child, then the child will just go there. And then if it has 2 children, okay. This should be fine. Okay, let's read some discussions. Yeah, this is pretty hard. If this is a median, I want to see how more complex examples will come in handy. One important detail that I think is missing in the description is that you do not need to swap the in-order successor or predecessor node or the node to be deleted. It suffices to only change the val field of the node. So what I'm reading is this one is a tough one, but we'll still solve it. If the root is a leaf node, then return null. Else, if it only has 1 child, return the left child. If it has a right child, return the try. Or the successor. Okay. This is our answer. Okay. So we need this one I need some, I'm gonna need some comments. No, new node, okay. else? Key is less than node. Key is less than node. Yeah, if key is less than node, then we go left. If key is greater than node, then we go right. We're probably gonna need another function, right? Find func to find lead node. And then we can just do find func BST. Tree node, and we're going to return a tree node as well. And then we can do something like var current node is equal to our root. Okay. So that's our start. Let's go here and then write our guardlet. We can just do guardlet root equals root, else we return nil, because we're returning a tree node. So here, okay. So we want to do recursion for the other ones. So we can do something like let. What do we want to do? We want to, if only has a left. Minimum key in the right. Okay, so we want to keep going. We want to find this, the leftist. Left node equals current dot left. Current node dot left. Then we just set our current node to our left node. And then we want to return our current node. This should work. So the in order successor this is talking about. So this function will help us find the lowest node by going to the left as far as possible. So we can use it in these two thingamajigs that I have here. So if our key is less than our root.val, then we know that our root left should be set to our BST, and we'll be passing in our root left in the key. Root left in our key, we need to return. We will return our root. Okay, we do the same thing for our right. Okay, so if our key is greater than our root.val, then we know our root right is equal to our BST, and then we're passing in our root right and our key, and then we are returning our root. Okay, so we have our left, we have our right. So now we need to handle when we are deleting. So this is just to let us know where the key will be. If it's less than, it'll be on the left side. If it's right, it's on the right subtree. Okay. So now if our left is nil, okay. So if our left is nil and our right is nil, we return nil. Okay. So if our root dot left is equal to nil, and then we need to do our right too. If they're both equal to the root dot right is also equal to nil, we also return nil. So now we need to do if only one of them is nil. So if root dot left is equal to nil, we know that we are returning our root right. And then we can do if our root right is equal to nil, then we know we're returning root left. Okay. So this is for when the node only has a right child, if a node only has a left child. And this is if they have no children. So we return nil. If it has a right child, return right. If it only has a test. Okay, so now we need to do if they have both children. So we know our thing only finds, okay, so we can do, what did this guy call it? Inorder successor. So let's do our successor. That will be our BST. We'll pass in our right. Okay. We'll pass in our root right. And then we need to replace our current val with our successor's val, or set our root val to our successor's val. I feel like I spelled something wrong here. And then we need to delete our root right. We are going to do some recursion. With our root right and our successor's right. And then we can return root. Let's see. Okay, that was a lot of code. Okay, so we have root. If our root is null, our key does not exist. So if our key is smaller than the node that we're currently on, then we delete. What am I doing? It should be this, not our BST. So yeah, this is what we're used to delete. So if the key is smaller, it's in the left subtree, we want to delete. Then the right, we delete. Okay. If they both don't have children, we return nil. If the node only has right children, and then if the node only has left, and then if this is for if they have two children, so we find the Inorder successor, which is the smallest value in the right. Then we replace the current value of the successor's value, and then delete. Okay, this should work. Return is not spelled correctly. Okay, test cases have passed. Now let us look at some. Let's submit it first. I feel like I was going to get a time limit thing. Okay, let's look at some solutions for Swift. That's the first time I think it's saved. Not really efficient Swift solution. Okay. So it is doing some recursion. I mean, it's not, yeah, it is doing recursion. Calling the delete. So it was doing something similar to what I was doing left, but then here. Var minimum val. Okay, it's calling recursion again. This is also similar to the one we just looked at. Easy to understand for beginners. No, it's not. This has two helpers. Wow. So this is what I had from the hint from the discussion. So we search for the node to delete. Okay. Okay. All right. So that was question number 450. Delete node in a BST.